In this video, we'll take a look at the iOS-specific terminology that you will come across as you develop iOS applications. You likely saw several unfamiliar terms when you started exploring the iOS projects and source files. In particular, iOS uses some terms which are also used in .NET that have a slightly different meaning in iOS, and we'll talk about these specifically and see how Apple defines them. Remember that Xamarin.iOS is sitting on top of Apple's frameworks, so when you see these words, it's very likely that it's the Apple definition you need to be thinking about and not the .NET definition. To start with, let's talk about MVC, or Model View Controller. Model View Controller is an established architectural design pattern used to logically separate the UI, the data, and the behavior of an application. The entire iOS API is built around this pattern, and its usage is enforced by the iOS API design. Now, the model represents the data that you'll work with. Now, the data is arbitrary. It could be internal data, it could be a database, or even a web service, but it will generally be some C# classes. And this part is defined by the developer, and for the most part, the iOS API is not concerned with this part of the MVC pattern. You just need to keep your data layer cleanly defined and separated from the other layers. Now, the view contains all the visual components that the user sees and interacts with, such as buttons, sliders, and text, all of which derive from a standard class of UI view. And views are composed and can be defined imperatively in code or declaratively using a storyboard or nib file. Interaction between model and view is always done through a controller. So if the user changes data in the view notifies the controller, and the controller updates the data. If the data is changed, perhaps reloaded from a web service, and the controller then pushes updates into the view so the user can see them. Let's bring this back to our project. When the app launches, the main method will launch the UIKit framework and point it at the app delegate. The app delegate creates the primary window, which will provide our visual surface. And it has a property named window of type UI window, which must be assigned. Now, the system will assign it automatically if you're using a storyboard, or you can set it yourself. And the UI window class must be passed the rectangle which it will be able to draw into. Typically, we would want to use the entire device screen, and this is defined by a static property on UI screen named mainScreen.bounds. Remember that controllers are represented by the built-in UI View Controller class, and your app will always have at least one custom view controller, and will often have one for each main view or screen that you display. Here we've named one My View Controller. We need to create an instance of this class in our finish launching override and assign it to the Windows root view controller property. This is what identifies this as the starting screen for the app. The final step is to make our window the key window and return true from the method. This specifies the window to receive touch events and is done by calling the makeKeyInvisible method. Now we've seen all the pieces, let's recap by putting it all together. Things in gray are provided by iOS, and the blue boxes are things that we supply in code. We start at the main method. This is the first spot where your code executes. And main is responsible for initializing UIKit by calling UIApplication.main. That will create the UI application and app delegate singletons. Most of the time, iOS will create an instance of UI application, but you can provide your own derived implementation and specify it as part of the call to UI application main to tell iOS to create a specialized version. And that's why it's divided between an iOS system class and your own custom class. UIApplication.main will also read the info plist, and it'll read those settings and populate the UI application and other internal data structures with the metadata. Now, the UI application class then starts the run loop. This is a message loop that processes the UI events from UIKit within our application and runs it continuously on the main thread of our app. If you block the main thread for any length of time, it will cause your UI to freeze, just like in Android or Windows. UI application will then call the finish launching method on your app delegate class. You saw this code in the application we created and in the last slide. And the finish launching method is responsible for creating the UI window for the device screen and assigning the root view controller to represent the initial screen. These steps are all either done in code when you need to control the visualization or you want control over the process, or by an associated storyboard. So what is a delegate in iOS? You just added code into a class named AppDelegate, and the AppDelegate is a required and necessary part of your app structure. iOS calls methods on it to let you know that things are happening, for example, that the app is loading. Now in .NET, a delegate is a type-safe callback or method pointer. In iOS, a delegate represents a set of methods and properties that are used for notifications. And they're used all over iOS for notification and behavioral customization. In Xamarin.iOS, you must implement a delegate handler class and then set a property on the publisher to point to your delegate implementation. So the publisher sends messages to the delegate to determine whether an action should be taken, or to inform that an action will be taken, or to inform that an action did happen. Now, message names reflect the purpose with prefixes should, will, and did. And Xamarin.iOS will sometimes drop some of the prefixes and rename the methods to be closer to .NET conventions. Now, the actual contract that defines a delegate is defined by another interesting feature in iOS, a protocol. Now, protocols allow you to define a standard abstract contract of methods and properties independent of the class that implements it. So kind of like an interface in .NET. Implementing a protocol in Apple's lingo is conforming to a protocol, and it's possible to conform or implement multiple protocols on the same class. Protocols are similar to interfaces, but they're not exactly the same. Protocols can define methods or properties which are considered optional to the contract, and they can also define static, called class-level operations, which do not require an instance to invoke. Xamarin.iOS uses a combination of interfaces and abstract classes to model protocols. It uses interfaces to define the intent, e.g. this class conforms to the protocol, and abstract classes provide the support for those required versus optional methods, and gives a placeholder for static method implementations. So abstract methods for required implementations, virtual methods with empty bodies for optional methods. Now your code should just derive from the abstract class. And even though you are deriving from a base class, you should actually treat it like an interface. This means you should not call the base class for a protocol implementation unless you know for certain that the method is implemented. Most of the time, Apple leaves methods unimplemented, and it will cause a runtime failure if you call them. And check the Apple documentation if you're unsure whether it's a protocol versus a real class.